So this will be a commentary for Topcoder's single round match 603 Division 1. So the 250 problem, you're given a tree with n nodes, and there's 2 players, and also each node has a cost. So players take alternating turns. The first player wants to maximize the outcome of the game. The second player wants to minimize the outcome of the game. What they do is they pick an edge and from the tree and erase it. When they do this, they split up the tree into 2 sections. Okay, and then the player decides which component to keep. Because there's 2 components, he keeps one, they keep playing the game. At the end, the game ends when we have 1 node left, and that will be the result of the game. So, as I said before, the first player wants to maximize, second player wants to minimize. So, if both players play optimally, what is the result of the game? So, for me, this was really easy to see that if you pick a node, a leaf, you will for sure look right away. I'm done coding it. So if you pick a leaf, so that is a node with a degree of 1, where the degree is the number of edges coming out of it. So if you take those, if you're the first player, if you consider the leaf nodes, if you pick the leaf node with the highest number, that will be the optimal move, always. And here's why. Suppose the first player does not pick the highest node. Okay, you pick the edge and then you have to pick the components. But suppose he doesn't pick that edge with a component, so you'll get something else. Then the second player, he is able to do the procedure optimally. So he picks the leaf node with he picks the edge such that the resulting leaf node is a minimum for him. So in this case, the first player, he did not play optimally because he could have gotten a higher number on his first on like the first round. On his turn, he could have gotten a higher number than he got at the end of it. So we know that his first move was not optimal because we assumed it was optimal. So that is the proof, right? So he has to pick the highest leaf node that remains when you take an edge, a leaf edge, I guess. So that was the solution to the problem. So right now, I'm working through, I think, the 1000 problem. So first I tried to at least recreate the example and see what results I would get. I was almost able to code this one. I was able to get the right solution, but again, it was not optimal, not efficient enough to run on time, and so I did not submit. So I don't know, I tried in the practice rooms to optimize my solution little by little, but I wasn't able to get it to run on time. I don't know if there was any way to do it. I think, let me read out the problem statement. Okay, so the hero has two arrays of integers a and b. Each of the arrays contain n elements. So hero will do two things with his arrays. First, he will permute the elements in each of the arrays somehow. Okay, so he is allowed to put the elements of each array into any order he likes, including the original order. He is not allowed to swap elements between A and B. Each array has to be arranged separately. Afterwards, he will produce a new array C of n elements such that all Ci are equal to the sum of Ai and Bi. Okay, so here likes equal numbers. His goal is to produce as many equal numbers in C as possible. Formally, for a given C, he's interested in integers x and y such that C contains x occurrences of y and x is as large as possible. So we need to find the number that occurs as much as possible once you do the sums. So you're given an int n and vectors a seed and b seed, so that's how you produce like the first numbers, generate the arrays of a and b. So once you have the arrays a and b, your task is to compute the best possible pair x, y's. That is, x must be as large as possible, and if there are multiple pairs, then return the one with the largest y. Okay. So I believe I brute forced this one, but I had a bunch of optimizations. So I don't think I could have gotten it to work even with my algorithm. Maybe I did not remember that we actually had 4 seconds to submit the solution for this one. 4-second time limit. So that's not the standard. It's usually 2 seconds. I don't think that would have made a difference for me. So I really spent most of my time there on that problem. I've never been able to solve a 1000 problem in Division 1. Not many people get them correct, like maybe less than 10 people per match, so I shouldn't feel too bad about that. So here I'm trying to code it in C++. I had promising results on Python, but I made some assumptions, like the size of the two sets, like their sums was low, and then I could brute force it somehow, but that was not. I only tested it for one test case, and it was not the case for all other test cases. So that's why my solution did not run efficiently for other test cases. And so feel free to watch the rest of the video, but my commentary ends here.